Hello, and of course, welcome. Now, if this is your first time coming along, you are most welcome. So get your notepad out, strap up, be ready for the ever so exciting journey of learning. Now, I want to get a few things clear before we carry on into the topic at hand, which is analytical geometry. Now, if you're looking at this in 2025 or at any future point in time, and you are anywhere in the grades of grade 10 to grade 12, this is tailor-made for you. So strap up and get your learning gears on. So on our introduction to geometry, it's gonna be a series of a few videos. Now, in this specific video, I'm only gonna be focusing on part one of our introduction to geometry. Now, what you see on the screen here is just me hyping you up and preparing you or giving you an insight as to what is to come in part two of this analytical geometry video series. So, without further ado, let's start this series on a very high note. Here's what to expect. In this part, I'm just going to reverse with you what you've done in the lower grades, between grade 6 or grade 4 and grade 9, essentially. That's what this is. This is going to be what part 1 of our video is going to be comprising of. This is what this part of the video is going to be comprised of. So before I get you bored and snoring or your attention draws away, let's get to it. This is not to say I'm assuming that you guys aren't familiar with these things. I'm trusting that you guys are very clever. You are familiar with these things, but I'm playing the role of a coach or the role of a tutor. My job is to guide you to make things simpler. So to remind you, geometry is nothing but the study of shapes. That's what geometry is. Nothing but the study of shapes. Now, when we are dealing with shapes, we are just going to be concerned with primarily two things. One being the angles the shape has, and secondly being the sides the shape has, A, B, C. So in this, the first triangle, first type of a triangle is an equilateral triangle. In this triangle, all three sides are equal and all three angles are equal. So when three angles are equal, three sides are equal. That's what I need you to remember, right? That's simple. Three angles are equal, three sides are equal. Then moving on to the second triangle. In our second triangle, let's call it triangle DEF. In triangle DEF, we have two sides that are equal. In these two sides that are equal, the angles that are opposite to those sides are also what? Equal. That's what I need you to take away from this, or that's what I need you to remember if you already knew that, right? And then moving on to the third type of a triangle we have, which is a scalene triangle. Now, this scalene triangle, let's name it triangle GHI. In this triangle, none of these three angles are equal. None of these three sides are equal. So no equal angles, no equal sides. That is what I need you to take away from this. The scalene triangle, no equal angles, no equal sides. This one, two equal angles, two equal sides. The equilateral triangle, three equal angles, three equal sides. Simple enough. Moving on now. Moving on. Now, we also have a different variation of these types of triangles. I still say we have three types of triangles. Now, the isosceles one is very naughty, just like the scalene one is naughty. You see, the equilateral one is very well behaved. It always has three equal angles and three equal sides. That's it. But these two, naughty ones. Sometimes they come in the form of a right-angled triangle. This right angle you see in here. That's what they do sometimes. That's what I need you to take away for yourself. So if this is a right angle triangle with two equal sides, if two sides are equal, it means two angles are going to be equal. Which two angles are going to be equal? The angles that are opposite the equal sides. This angle is opposite this equal side. This angle is opposite that equal side. Done and dusted. If you grasp that, we are done with the isosceles triangle, right angle triangle. Now let's move on to the scalene kind of a right angle triangle. Now in a scalene triangle, none of the sides are equal. This side is the longest side of a triangle. The hypotenuse, the side that is opposite the right angle triangle. And then none of the sides are equal, but we have a right angle in here. So this is a right angle triangle. None of the angles are going to be equal as well. None of the sides are equal. None of the angles are equal. So let's just expand a little bit further into these right angle triangles and now introduce the theorem of Pythagoras. Now, to those of you that already are a step ahead or so, you may have already picked it up, what I have in here. Oh, flip. I have in here for you, I've drafted in here for you the theorem of Pythagoras. Now, the theorem of Pythagoras that I have in here, it speaks to when only and only if we are dealing with a right angled triangle. Now, when we have a right angle like this one, we would map or label the side that is opposite that right angle as the hypotenuse. This hypotenuse of ours, or the side AC, our hypotenuse, the square of this hypotenuse, according to the Pythagoras theorem, hypotenuse squared, which is AC squared, our hypotenuse is AC, so AC squared, our hypotenuse squared, is equals to the square of this side plus the square of side BC. That's what this is saying. AC squared, the hypotenuse squared, is equals to AB squared plus BC squared. So to simplify the theorem of Pythagoras, I can say the theorem of Pythagoras can be defined as hypotenuse squared is equals to side 1 squared plus side 2 raised to the power 2. Simple as that, with AB being your side 1 and BC being your side 1. Now, to further illustrate, in this version in here, this part in here, we have nothing different from this. This is still the theorem of Pythagoras. How so? Well, let's look at this scalene type of a right angle triangle where none of the angles and sides are equal. We have a right angle at F. Now, this right angle at F is opposite the side DE. This DE is then our what? DE is our hypotenuse. Right? So this still says the hypotenuse DE squared is equals to DF. What is DF? One of the sides. DF is that side on top there, which is our side 1 squared plus the other side squared. Side 2, side 1. Right? That's what I need you to remember with regards to triangles. Now, the last little bit of information that I need you to take away from yourself for yourself with regards to triangles is, in analytical geometry, is the exterior angle of a triangle. This is now a reminder of what you guys, I believe, already know. Right? There's this theorem that says when we have a triangle and one of the sides is expanded like so, like this side is being expanded in here, and we have an exterior angle. Now, this exterior angle is going to be equals to the two opposite interior angle. Now, the two opposite interior angles in this case are x and x. So hence this angle is 2x. When the exterior angle of a triangle is always opposite to the two opposite interior angles. Just like this angle in here is 2x. How is it 2x? This triangle is an equilateral triangle. All the sides are equal. Therefore, this side is also, this angle is also x. So this exterior angle in here at B will be equal to 2x, because it is the exterior angle of a triangle that is going to be equal to the two opposite interior angles. Now, the two opposite interior angles in this case are going to be angle A, the x at angle A, and the black x at angle C. Right? That's the same thing that this schematic is capturing. We have an exterior angle of a triangle in here. Now, this exterior angle of a triangle is opposite angle, this angle in here. Let's call it angle D and angle E. At these two angles, angle D and angle E are opposite, the exterior opposite of that angle. So as such, they would be equal. Now, I'm hoping that makes a little bit of sense at this point in time, which is the same phenomena that we are trying to capture in this part in here. Let's look at this angle. Let's call it angle F, angle G, and angle H in here. So this angle F is the exterior angle in a triangle where the straight line is extended like that, like so, right? And then this angle would be equal to the two opposite interior angles. There are two opposite interior angles being angle X at G and angle Y at H. That's what I need you to remember with regards to triangles. Now, everything I said you need to remember about triangles I've said in this first 12 minutes. From here on in, I am saying nothing of triangles except the fact that all the angles of a triangle always add up to 180 degrees. Hence, the 180 degrees in this corner in here. Hence, the 180 degrees here at the bottom. That's what I need you to take away for yourself with regards to triangles. Capiche? Come on, say along, Pella. Capiche means understand. Capiche? Part of me can hear you say capiche wherever you are. So if you didn't say it, I'll deal with you later. Moving on. The quadrilaterals. Quad means four. Quadrilaterals, we are talking the four-sided shapes. So I have paired them in two twos. So we're gonna essentially have three pairs. In pairs of two. We have a total of 6 quadrilaterals that we need to be familiar with. I'm just showing you a flash of them in a nutshell. So let's start with the first two. Now the first two, I call them the equals. Why do I call them the equals? It's because in these two shapes, all of the sides are equal. This side, this side, this side, all of them are equal, right? So hence I'm calling them the equals. Just like in this second shape. Now this first shape, needless to say, the name is there. It is a square. In the second shape, the same thing happens. It's similar to a square. However, unlike the square, it doesn't have right angles. It doesn't have right angles. It has opposite angles that are equal. This angle is opposite this angle. The opposite angles are equal. Now this angle is opposite that angle. The opposite angles are equal. But much like a square, a rhombus has all of the four sides that are equal. This side is equal to that side, which is equal to this side, and which is also equal to this side. Like the square, the rhombus has opposite sides that are parallel. This side is parallel to that side. The arrows mark parallelism. This side is parallel to this side. Same applies in the square, right? This side parallel to that side in the rhombus, within the square, this side is parallel to that side. So what I need to tell you to take away, or need you to remember with regards to the square, is that all of the angles are 90 degrees, or right angles. Opposite sides are parallel and equal, and all sides are equal. All sides are equal in a rhombus. Opposite sides are parallel and equal, and opposite angles are equal. That's it about the equals. Now, if you need to recap or a better explanation, please comment down below or hit the Q&A section if you are in the inner circle. For those of you that need to recap, go back, start at 13 minutes or 12 minutes or so, and do the things. Moving on to the next pair. So we've done the first two shapes. Now we are down to the second two shapes. So we are up to 4 shapes now. We have a total of 4 shapes that we need to cover, and then this video is done. So bear with me just a little bit while longer. We have in the left hand side here the rectangle. Now a rectangle has opposite sides that are equal and opposite sides that are parallel. A pair of these are opposite, equal and parallel. A pair of sides that are opposite are parallel and equal. All of the angles are 90 degrees, meaning all of the angles when combined inside a 4-sided shape add up to 360. Always, all the angles of a 4-sided shape add up to 360. All the angles of a triangle. In a triangle, in a 3-sided shape, as we've studied, the angles add up to 180. In a 4-sided shape like this one, we have angles that always add up to 360 degrees. So much like the rectangle, our parallelogram has opposite sides that are both equal and parallel. Opposite sides that are both equal and parallel, right? But unlike the rectangle, you can see most the parallelogram is standing like the falling tower of Pisa or something like that. It has a slanting shape, right? The opposite angles, like a rhombus, are equal. The opposite angles, much like a rhombus, these opposite angles, they are equal. They are very much equal, right? That's what I need you to take away for yourself. Moving on to the next pair. That is it about the pairs with opposite things that are equal, opposite things that are parallel and equal. Now I'm going on to the next pair. Now these ones are the solos. They stand out. They don't have any shape that has a lot of similar properties. You've seen that the rhombus and the square have a lot of correlating similarities, just like the rectangle and the parallelogram have similar or correlating similarities. These ones, I call them the solos because they stand out. So on the right hand side here, we've got the trapezium. The trapezium, there's nothing much to it other than the fact that since it's a 4-sided shape, every 4-sided shape has angles that add to a total of 360 degrees. I meant degrees, degrees. Saying potato. Right. But the thing to note, or the nice thing about this trapezium, is that it's not as much complicated about all those other shapes, so there's not much detail to remember other than the fact that none of the angles are equal. All of these angles, when they are combined, they are gonna add up to 360 degrees, right? And also remember that the opposite sides are parallel to one another. Opposite sides are parallel to one another. None of the angles are equal, but all of these angles, when put together, seeing as it is a 4-sided shape, they add up to 360. That's it about the trapezium. Any puts or questions? Going once, going twice. Sold. If you didn't, let me not say much. Moving on, the kite. With regards to the kite, It's a four-sided shape. So seeing as it's a four-sided shape, all the angles are going to add up to what? 360 degrees. Still simple. Now with the kite, we have an adjacent pair. This adjacent pair in here, that is equal. And then we also have another adjacent pair. So that is equal. So we have V pairs in simple terms. V pairs or adjacent pairs as we call them as per the language of mathematics, right? So adjacent pairs are equal inside this friend of ours. Inside this friend of ours, adjacent pairs are equal. This side is equal to this side, that side equal to that side in there. What else about the kite? The kite has the angle between the set of adjacent pairs, meaning the angles between the V's. You can see there's this upward V and then there's this V at the bottom. The angles between the V's, they are 90 degrees. Take that away for yourself. And then when we have diagonals, the dotted lines that are drawn from the corners like this, the diagonals meet at 90 degrees, and these diagonals cut each other in half, meaning this diagonal, this part of the diagonal from here to this corner in here is going to be equal to this part all the way to this corner in here. The diagonals bisect when we are talking mathematics. Now, I didn't say much about the diagonals with regards to the other four-sided shapes. I will be applying those as we go along in exam, past paper practice, and such types of examples along the way. I didn't want to make this video too long. It's already about 20 minutes. So, ladies and gentlemen, or my fellow mathematicians who've reached the end of our video. So if you've got any questions, please hit me in the comment section. If you're in the inner circle, in our teams group, please be sure to hit the Q&A sections. Myself or one of our tutors will be sure to come to your aid. Let's keep going. Let's prepare for our June exams. Best of luck. One peace, one love. Thank you very much. In the next part of our video, we are going to be going into analytical geometry in the context of now analyzing all of those shapes in the settings of a Cartesian plane. So meaning all of those straight lines that make up a square, or the straight lines that make up a triangle, the straight lines that make up a trapezium, are going to be straight line functions in and of themselves. So which is why in the next video, the first thing we are going to be doing is to revise what we know about analytical geometry, or not necessarily analytical geometry, but more so about linear functions, seeing as every straight line that in that Cartesian plane, doesn't matter if the straight lines make a triangle, a square, they make a rhombus, every straight line is a what? Is a function, is a straight line function. So hence this, I'm showing you the screen. This is the first thing we're going to be discussing in the next video. Stay tuned. Bye bye. See you in the next one.